is Voyaager of the Seas. It is the first of the Eagle-class ships, the largest cruise ships ever built. At 137,300 gross tons, it is nearly a third larger than the largest nuclear aircraft carrier. In the next hour, you will see how this ship is built, fitted, and tested. There will be times of triumph.
Yes.
And dramatic setbacks. We will accompany the officers and crew on the first sea trials, and we will see how they put this ship through the extremes of performance.
I'm Roland Smith, and this is the story of the creation of Voyaager of the Seas.
The Kvarniemassa shipyard in Turku, a small town in Finland's southwest corner. A town where shipbuilding has a long and proud history. Turku, also known by its Swedish name, Abo. It's quaint and quiet. In summer, when the sun literally never sets, people enjoy the parks, the river, and the surrounding archipelago dotted with picturesque islands. In the winter, the river freezes. The saunas are kept warm. There is light for only a few hours each day, and it's cold. So cold, in fact, the seawater actually freezes more than 1 foot deep. Turning the idea of a big ship into a big ship is a tribute to the talent, ingenuity, and collective intelligence of thousands of people worldwide. Already thousands of hours and hundreds of meetings have taken place in the design and planning process. 28 architectural firms from around the world prepare drawings, renderings, schematics, and blueprints, which the yard architects must then review and often modify to make them work in the ship's total layout. Each area of the ship is assigned a specific design and engineer team who monitor their area throughout the construction process. It has been over 3 years in planning. We begin this part of the story on a cold, wet morning on the edge of the shipyard. Raw steel sheets from the mills in the north are brought into the yard. These sheets will be the first steel to be cut to become the parts for the hull, decks, and structures. As the steel moves inside, it is sorted, marked, and it begins its journey to the ship. One of the many Finnish shipbuilding traditions are ceremonies to mark milestones in the birth of a ship. Every major step in the process will be celebrated with a ceremony. The steel cutting ceremony is telecast by satellite to a group of top travel agents gathered in a New York restaurant.
Hello New York, hello Richard, and you are all warmly welcome to a short visit in our yard here in Turku, Finland. And we are very well prepared to start the work on this big project, our new building number 1344. Now going to be the first.
The marketing effort has also officially begun.
On the table over here. This is the place we start. And here is the double bottom section, of which the two parts belong to. And these are the longitudinal keels you can see here, these two plates. And they are now situated here below the steel cutting machine.
Cutting the first piece of steel means the ship has truly begun construction. These plasma cutters are computer controlled and cut precisely through inch-thick steel like butter. They operate at 22 to 25,000 degrees centigrade. The cutting is all done underwater. The water cools the surrounding steel and keeps the intense heat from warping the metal around the cut. cuts are checked, and the piece is marked with a number and a drawing which will stay with this plate all the way until it's in the proper place in its part of the ship.
Please, this is done.
All the parts are pre-assembled. They come together Lego-like. By the time it's done, there will be in excess of 300,000 steel pieces. No one will ever know the true number, since many pieces like small supports are made in large numbers and used in addition to the parts in the drawings. Without the detailed plans, it's impossible at this point to know what you're looking at. Most of the blocks are built upside down. It's far easier to install the plumbing, wiring, and even air conditioning units and ducts in the ceilings. Here, Captain Olaf Neister, along with the construction supervisor for this block, the foreman, and the official inspector for the certification agency, Det Norske Veritas, go over every weld and component.
You have to inspect the small pieces before they become large pieces. This is the top. This will be, of course, white painted and so forth. And the deck will be up above. So when you're inspecting steel sections, you have to bear in mind they are turn around.
And everything's upside down.
Right here, it's a very weak point. So they have to put on some brackets, some stiffeners.
Structurally, the ship is quite sound, as designed. The added reinforcements do have an effect in cutting down on vibration and stiffen and strengthen certain areas even more. It is far easier to add them now than later. And the process goes on for every brace, every plate. Over 300,000 pieces of steel to cut, fit, and weld. The reality of just how big and how much more there is to do, more than anyone imagined, is just beginning to sink in.
I think the short building time is a key. We are, it's stressing us and it's stressing the art, surely. And that will be something that will be, I think, most of a challenge during this period for us and for the art.
This tunnel bored through solid rock allows vehicles to enter the huge dry dock. Placing the first grand block, which by itself weighs in at over 600 tons, marks the point at which the ship will be assembled into a form we will soon recognize. A Finnish shipbuilding tradition is to place coins minted in the year of construction under the first block. Later, when the ship is floated out, they will be retrieved and put on display. Despite the bitter cold of the winter afternoon, spirits are high as the first block is carefully lowered into place.
Yes!
The exact placement of the block on the concrete and wood supports is critical. So critical, lasers are used to measure distance and position. This is the center of the ship, and the rest of the blocks will be built out and up from this point. A slight misalignment here, and the ship may not fit into the dry dock when they get to the ends.
To give you an idea of how large this dry dock is, take the Empire State Building, knock off the antenna, the television tower, and another 50 feet, and you could put the Empire State Building from that end to that end of the dry dock. That ship, when it's finished, will fill this lengthwise.
The first blocks to go into the dry dock have the tanks and pipe fittings already installed.
And then there is also a wish to have more pattern.
At the same time, the interior designs are coming together.
To this level.
This is the most comfortable chair that you can play cards in that is also stackable.
Then you've got the tee, you've got the golf ball.
We have 5 different colors.
You mean the 5 different stools are 5 different colors?
Yeah.
On purpose?
On purpose, yes.
The construction continues through the winter as more and more recognizable sections take form. This is one of two specially built trucks which carry the huge blocks from the assembly buildings to where the 600-ton crane can lift them into the dry dock. Every set of wheels in this machine turns, and the entire vehicle hydraulically squats to move under a block, then lift it. This is half of Studio B, the theater, television studio, and ice rink all rolled into one. The form and structure are becoming recognizable, where the audience will sit, the arena, and so many details to be finished in each block even before lifting, like insulation and plumbing.
This is the stage is these are lifts, is to get use the sets and production values here for the ice rink and to get the skaters on and off the ice. So we've constructed ramps made of glice, which is a plastic kind of ice, so they will mount stairs here and skate in from these areas. Well, the first half of the show is a international ice skating spectacular, complete with flying using the Foy flying rigs. So we'll have skaters flying a la Peter Pan.
Flying even higher than the ice skaters, these blocks of steel are carefully lifted into position. Similar to the connected floors in a modern skyscraper, each block of the ship derives much of its structural integrity from the pieces around it. So when it's lifted, it is not anywhere near full strength. Lift it the wrong way, and it could bend, crease, or even collapse. Interestingly, many of the crane operators are women. According to a yard supervisor, women operators often have a better touch with the cranes and cause less damage. In his words, they are more patient. The big lifts are complicated and dangerous. Too much wind and work has to be halted. Crews have to guide, position, and secure each section. Tricky work, standing high atop steel in the cold wet of the Finnish winter.
The maximum weight of one grand block is 600 tons. That's the maximum that we can lift at one lift into the building block.
This huge block, built upside down, has to be turned over before it's moved into position. It's big, heavy, about 500 tons, and rotating it is tricky and dangerous work. Fortunately, no one is allowed underneath during any of the big rotation lifts. Voyaager will need 6 huge diesel engines to drive her generators. The Wärtsilä engines are chosen for their reliability and the fact that the factory is in the city of Turku. Each diesel has 12 cylinders and is rated at 17,140 horsepower. In its parts and pieces, these precision machine giants are more like works of art than machines designed to work around the clock, year after year.
We have so many new things, we have so many new pieces in the puzzle, so that we wanted that in the areas like the power plant, so that we concentrate on a solution which is well proven. That's why we went for the diesel engines.
Each is built up and must undergo rigorous power runs and adjustments at the factory before they are ready for delivery to the ship.
We are amazed about actually this power station. It's so stable, always running with several engines parallel there. I'm really surprised about these diesel engines. They go from 0 to 100% in just 28 seconds. They just pick up the load in 28 seconds up to full load from an idling engine.
bigger than a bus and weighing 185 tons, each diesel engine arrives by barge from the Wärtsilä plant in Turku, just a few miles away. They must be hoisted into position before any block can be added above them. All the essential plumbing and piping have been pre-built into the blocks. It's quite an achievement that so many components built in different parts of the world come together with remarkable precision. Eight months of assembly and lifting becomes a ballet of cranes, steel, and workers, captured through the magic of time-lapse on a scale so grand as to defy the senses. The 29 elevator shafts are built on shore, then lifted into position in one piece. The first shaft is hoisted, ready to go in, but the lifting points are not correct. It doesn't hang straight, and with the tight fit, it must be exactly vertical. It takes nearly 3 days to get it right, but now the technique is perfected and the other shafts will go in far easier. The tolerances are very tight. Placing a shaft this long into a narrow opening down 14 stories is no easy task. The precise alignment of huge blocks has been near perfect up to now. Halfway in, this one jams. The men consider the options. Force it too hard and the shaft may bend, causing delays and repairs. Work in this area will come to a halt until a solution is found. The foreman comes up with an answer and the men move to all levels. A few wedges plus some well-placed slams of a big hammer, it finally slides into place. Each cabin is pre-assembled with plumbing and electricity, even cabinets. Marked for exact deck and position, covered with clear plastic, then black plastic, and shipped back to the yard.
As today is the 1st of April, we are now in good progress with the production of cabins. The production is in full speed. The largest challenge for us in the cabin factory in this project is of course the size, the huge size and tight building schedule of this project.
There are nearly 2,000 miles of wires in Voyaager, and every one has to be laid in, connected, and checked. It's a huge job, which will continue all the way through to delivery. The isopods are attached while the upper section of the stern area is still open. The thickness and design of the steelwork in this area is far more massive than other ships. The huge bronze propellers are made in Russia. They are manufactured in a factory which used to make propellers for Russian submarines.
The old propeller shafts are gone. We're going to have 3 pods where the pod actually hangs underneath the vessel and holds or encloses the electrical motor which will be propelling the vessel. The one in the middle, the center line, will be fixed and it won't be movable, but the 2 on either side will be azimuth pods, meaning that they can rotate actually 360 degrees.
The 4 bow thrusters have more power than the ship Song of Norway has for its main propulsion plants. They are 11 feet in diameter and have reversible props. The electric motors are rated at 4,000 horsepower each.
We have simulation tests at this point that are indicating that the vessel will be fully maneuverable and up to 40 knots of wind, which is almost unheard of.
Operated by hydraulics, the 4 stabilizers are extended at sea to minimize the ship from rolling and keep the passengers from getting seasick. They are retracted in port so the ship can dock. Inspections continue by the yard, the certification agency, and Royal Caribbean. The certification agency will spend 6.5 man-years, that's over 10,000 hours, inspecting the ship during construction and sea trials before she is certified to carry passengers. From the beginning, there has been concern about the atrium fire doors. Both the United States and Norwegian authorities demand extensive testing to prove the design will actually work when the ship is moving and rolling. The uppermost decks are made of aluminum, not steel, to preserve stability. Today's ships are welded, not bolted or riveted together. Welding is far stronger and waterproof, but steel does not weld to aluminum. In order to join the top structures to the steel decks below, special bonding plates have to be made. A piece of heavy steel and aluminum are brought together under high pressure and in a vacuum. With an explosive charge between them, they are literally exploded together, resulting in a single piece of metal with steel on one side and aluminum on the other. It is literally an atomic fusion of the 2 metals in the middle. The process is called blast welding.
We are in the forward part of the vessel, up on the sun deck, and what we see here is the aluminium and the steel joint. We use a lot of aluminium on top of the vessel to save weight and to get the center of gravity down, to have the light material on top and the heavy material down, and we get the center of gravity down and good stability for the ship.
The final major block, the aft stack structure, is moved into place. It has been a wet and cold week, and the top of the ship is coated with ice. It's over 200 feet up, and this work is getting dangerous. Finally in position, the block is close, but the cold has affected the shape, and it does not fit into the attachments. It takes a sharp eye and brute force, but finally it is in position, ready to be welded. Voyager is nearly ready now to float out. Some of her systems are being tested, tanks and valves are checked and double-checked. Accidentally flooding a compartment during float-out would be very embarrassing. It's the day before float-out, and preparation continues. Water will be let in slowly through these giant valves, gently lifting the huge ship off the construction blocks. Thousands of gallons of water will be pumped into ballast tanks aboard the ship. The calculations must be very exact because the ship must lift off the blocks evenly. An uneven lift, front to back or side to side, would put enormous weight on one small section, and it could cause hull damage. The ceremony to open the valves is held in the late afternoon. With only 6 hours of sunlight, it's already dark. There is a crisp Arctic chill in the air, but the excitement builds as workers and executives gather.
We're doing well, guys. Put your back into it.
The ceremony over, engineers and workers will watch through the night as the water flows in, adjusting ballast as the giant ship begins to float for the first time.
Watertight net inspection at about 9 o'clock in the evening, and the water level is 3 meters up along the ship's side. We are inspecting all the bottom tanks and the lower part of the engine room. We are down in the double bottom level, checking that everything is watertight.
It was very interesting last night watching when the water first started to touch the hull. It was like the water met something where it was supposed to be and where it belonged. This is absolutely the moment she is born. This is when she is coming to a right element. Even if she started in April, she was not really born. Today she get her soul and she is where she belongs. Absolutely. Very exciting.
When the water level equals the level of the ocean, the end of the dry dock is removed. Ever so slowly, the ship is eased out and moved the 1,500 feet to the fitting out dock. The first order of business at the fitting out dock is to connect electricity and heat from the shore. Winter is a brittle time in Finland. The cold moves into everything and stays there. Ambient heat disappears in moments, and despite the constant freeze, construction continues, with over 1,000 workers on and off the ship each day. Just the normal process of construction creates a potential hazard, even though safety precautions are taken. Precautions are only that, precautions. Mistakes and accidents can happen because unforeseen conditions combine into explosive potentialities. On Friday afternoon, February 19th, what is feared might happen, does. A welder working on a section of infrastructure is unaware that the showering of his sparks are falling near barrels of highly flammable fluids on the other side of the bulkhead. The fire on Deck 1 quickly spreads to construction materials stored in what will be a food storage area. The welder discovers the fire and sounds the alarm on a temporary system. He makes an attempt to put it out with an extinguisher, but the fire has already grown too large. The amount of smoke leads everyone to believe at first that the fire is much larger than it actually is.
So here you see the difference between that side where the fire started and then the other side where was only one fire door fighting against the fire.
The fire was rather small but destructively hot. Some interior bulkheads, deck plates, and one main support must be replaced. A task that is time-consuming but not difficult. The setback weighs heavily on everyone, and the disappointment is evident on morale. The challenge now is the clock. Delay, a prospect that is costly to both the owners and the yard. It is now March, and time is the enemy. The contract is rewritten to reflect a new schedule, moving delivery now to October 29, 1999. It is unknown if the yard can even meet the new schedule. Any extra time they did have is now gone. 2 separate sea trials are rescheduled into one. Not much time for all the finish work, crew training, and crossing the Atlantic. Work on the remainder of the ship continues. The thousands of wires, connections, and systems each have to be connected and tested one at a time. The delays have a ripple effect as everyone must adjust to the new schedules. As each area of the ship structure is finalized and inspected, the craftspeople begin to come aboard, working their magic in tile, mosaics, fine woodwork, and finishes. Little by little, the adornments and parts which make up the spectacular interiors begin to emerge from the steel. And as soon as they are finished, they are covered and protected from damage as heavy work continues around them.
But it's the proportions are just terrific. You really get a good sense of it.
And the extra width what we worked here, the extra 1 meter.
That extra 1 meter was well worth it.
Was really well.
1 meter makes a lot of difference.
Where is the meter?
Well, it was going to be 8 meters, and we kept insisting it be 9, and they found a way to, and you can see it's actually, the bottom decks are 8 meters apart, 9 meters apart, and the top ends up being 8 meters apart, so that's why it slopes in a little bit. And that extra meter just makes the space so much more balanced, so much more human scale. I love it.
The promotional tour, which included England and New York, is canceled. It is a serious blow to the sales effort.
When it comes to sales, we are extremely dependent upon the travel agency distribution system to find our customers for us to close the sale. So the sales organization here at Royal Caribbean domestically is spending almost 100% of its time working with travel agents on all sorts of issues and helping them to do their marketing, which tends to be very much on a local or regional level.
Sea trials are at a time when the ship systems are brought up to full power for the first time. There are literally hundreds of tests to be completed, and there are also craftsmen on board, working on everything from tile to wood to cabin finishing. A total of 350 people board the Voyager in the Turku yard starting at 6 a.m. on Tuesday, June 29th. There are technicians, workmen, managers, a galley crew, a nurse, 5 captains from Royal Caribbean, plus specialists in every area. A large crew from the yard and inspectors from the ever-present certification agency Det Norske Veritas, they're all on board. They must sign off each major test before the ship can be certified. When the ship leaves the yard, 4 tugs are used to move the ship through the narrow and shallow channel. A huge crowd is on hand to watch as she puts to sea for the first time. The first test is anchoring, making sure that if the ship becomes disabled, the anchors work. The engines are brought online, and the ship finally begins to move of its own accord. One tug follows the ship on standby for the first 3 days, just in case. After just a few hours, the first trouble shows up as a fault warning sounds on the starboard azipod. The warning on such a critical system is taken seriously, and the ship is stopped until the problem can be found. It is the first of many delays in the testing process. The propulsion system starts with the big diesels, which drive generators. The electricity from the generators then goes to a huge power switchboard. The power goes into giant transformers, where it is split into the right voltages for use on the ship and for propulsion. The electricity for the propulsion then goes into a cycloconverter, which controls the azipod's speed, direction, and power. From there, the electricity goes to the pod electric motors, which turn the propellers. The problem was on one of the control cards in one of the 3 cycloconverters. The fault was on an integrated circuit smaller than a thumbnail. A new circuit board can be brought from the yard and installed. There are no spares on board, so a whole new card is borrowed from the second Eagle ship, Explorer of the Seas, now under construction in the dry dock. 8 hours later, everything checks out in the master control room, and the trials continue. The automation and autopilot systems, some of an all-new design, are put online for the first time, and they function perfectly. Captain Akusti Kovalinen, much like a test pilot, is in charge of sea trials, and he is impressed. The bridge is the largest ever built. Its control areas look more like a scene from Star Trek than a ship.
You know, that's how it looks to me too. It's like Star Trek. It is very much different from the way I have been used to do it. I've never sat in a chair to do all my work from the bridge.
As the captains put the controls through test after test, everyone is clearly amazed at how well the ship handles. Speed is one critical test. The ship must achieve a certain cruise speed at a given power setting, or the yard must pay a penalty. During the speed test, the pressure and tension is obvious.
Yeah, the official speed they have to calculate and correct for the power and for the water depths and for the waves and the wind and for the draft, displacement, water temperature, density. Lot of corrections. That takes a little bit of time.
The contracted speed, which must be met, is at 75% power, not full power. Speculation about what the top speed will be is debated all over the ship. A pool has been started to guess the speed, and the official results will be announced later in the sea trials. Captain Pedersen is even in on the pool. His reaction after one of the speed runs is telling.
My guess was slightly above 23 knots. However, it seems like now it will be slightly above 22. Speed, of course. I'm not disappointed with the speed. I just made the wrong guess. It's not official yet, but the speed was 22.77.
Very, very
so the speed will be around between 22.3 and 22.5 after it's corrected. So that's better than anticipated.
Yeah, she's doing very well. Magnificent.
Captains Pedersen and Favelin experience how good the azopods are for the first time.
You know, from what I have seen since we left the pier on Tuesday morning, it has been handling much better than we ever could have thought in advance. She is doing so well that she is like a small yacht when it comes to handling. You can do anything with this ship.
The stabilizer tests require everything on board to be lashed down. The ship is then forced to start rolling up to 5 degrees side to side. Then they engage the stabilizers and see how quickly they steady the ship. The tests are repeated at different speeds for several hours. All the elevators are turned off during the test as a precaution, and the 10 stories of stairs from the bridge to the master control room gives the men checking out the system a real workout. As the ship is rolled to one side, then the other, you can see what 3 degrees is like. Remember, the ship is certified to survive 45 degrees. But 5 degrees is the maximum for passenger comfort. The roll testing continues for several hours. Everyone will be relieved when it's finally done. At the same time, fire door testing is being carried out. The huge fire doors in the Royal Promenade work well. Only a few adjustments will need to be made to the hydraulics, but in the theater, one of the backstage fire doors simply does not work right. It will take days of fixing and adjusting to get it where these fire doors will be accepted by the inspectors. Every sensor, alarm, and system has to be tested one by one. The engines need to be run at full power and adjusted.
We discovered during the full load tests that some of the temperatures in the, say, the converters, the converter rooms, transformers, propulsion transformers, were higher than we anticipated and not as balanced as it should be. And we found that some of them needs to be adjusted. Those are not major. We have in some other areas adjustments that needs to be made that have a bigger consequence, but it's also things that can be dealt with relatively easily in the time that's left. But it's a job for the art, surely. So, but it's the purpose of this to detect these things and so that they can be fixed. Because once you leave the yard, forget it.
The days are long, the work never stops, nor do the countless alarms going off. Every fire and warning system is tested over and over. The fire systems are not fully functional. The crew sleeps when they can. The sea trials are now seriously behind schedule. It is announced that the ship will stay at sea at least 2 extra days.
The ship has behaved extremely well, despite that we had all the rush to get everything together. So from the functional point of view, everything has been going very, very smoothly. We have had a little bit hiccups with our measuring tools and with some of the procedures, and then we didn't reserve enough time for the various tests. We didn't remember that the ship is in every respect 50% bigger, and it takes a little bit more time to fine-tune 3 engines rather than 2, and so on. But technically, this is really, from the performance point of view, has been an outstanding sea trial. The
2 extra days become 5. Every day at sea is one less day in the yard where over 1,000 workers wait to continue their work. An innovation on the Eagle ship is what is called the ducktail. It is an extension over the stern.
The intention is to give a better flow for the water when it's leaving the hull, and you basically extend the length of the hull. And that reduces the resistance 3%. 3% every year, every day in the propulsion is quite a lot of fuel. So it's making the ship in consuming less energy, and that has been a part of that. We were a little bit worried in the beginning that if that is going to look ugly from the exterior point of view, but it fits extremely well there.
The wind is blowing at nearly 30 knots, but the day is clear and crisp. Today will mark the first landing of a helicopter on the pad at the front of the ship. This is the first on a cruise ship.
From day one, so what we decided is that we would like to have a good active helipad on this ship. The bow is superior location. I think this is enhancing a lot the safety. We need the helicopters among our passengers, so we have some air evacuation needs 2 to 3 times a year on every ship, so we do that. This is a safe way of doing that.
See if we can do something.
The ice rink testing runs into a few snags.
We also have a special ventilation system for this ice rink room to dry the air, so we don't get so much humidity in here. But that is it's not running 100% at this stage.
Will the ice crack when the ship leans and turns? That's the key question.
First we were making it as hard as possible to see if it cracks on the ship. The harder you get the ice, the easier it cracks. But the ideal temperature is about 4 or 5 below 0 Celsius on the ice.
The key element seems to be hardness. Make ice too cold and it becomes brittle. Too soft and it's hard to skate on. But overall, the tests are successful. And in these shots, I joined the Royal Caribbean and Cabernamassa people for the first ice skating at sea.
How good? A little rusty, but I'll tell you, it's a unique experience to be skating on an ice rink in the middle of the ocean. Whew.
Low on food, fuel, and supplies, and with all major tests complete, the ship turns toward the yard. The pressure is building in the race to finish and deliver on time.
Through the long Arctic winter, faces braced against the bitter cold. They lift, they shape, they build what man has never seen before. Into cold steel, they breathe heart and soul. From their hands a great ship is born. So many different faces, pride and joy along the way. These are the faces of the unsung heroes behind the scenes every day.
In part 3 of our story, you'll see how this city on the sea comes to life. We'll go behind the scenes to see how the shows are put together. You'll experience Voyager's momentous crossing of the Atlantic, and you'll travel aboard for her maiden voyage. I'm Roland Smith.